Hello everyone, this is Magda from the MVApp team, and today I'm going to show you how to fit simple curves to your data. So first of all, you need to upload the data. So in this case, I'm going to use the example dataset. Then we select, of course, the genotype, the treatment, and the trait that you would like to fit your data to. So in my case, right now, I'm going to select only the area. The other thing that your data needs to contain if you want to fit a curve is some kind of gradient, such as time. So in my case, this is day. And what I also need is sample ID. And that's because we're going to fit individual lines to individual plants as they grow. Click to set the data. Check if everything is all right. Okay, and then off we go to fitting the curves. So in here I select the phenotype that I would like to use for the modeling, how I would like to split. So I would like to split by treatment and by genotype. And to begin with, I have no clue which model fits the best. So I unleash the model estimation. It would just take a couple of seconds, and then we've got in here the message which of the model is fitting the best. So in my case, this is quadratic model. And that's based on the R-square values that are calculated in here only for the biggest group treatment for linear, quadratic, exponential, and square root models. So those are the simple functions that we're going to discuss right now. So based on those R-square values, the quadratic model is fitting the best. So that's also the model that I'm going to select from here. Unleash the model, and after a few seconds, I've got all of my data fitted with the square root model. And then I've got the delta, which is kind of like a growth rate in my case, because I'm fitting the curve to the area. So this is my growth rate, this is the intercept, so this is my starting point, and this is the R-squared value for all of my individual samples. So you can download this, and then you can also use your R-square value as a selection criteria for the outliers, because if your function is fitting very poorly, there might be something wrong. So how good your functions are fitting to your data points, you can see it using the fit plot. So in here, you can select individual samples, or you can have a look at multiple plots at the same time. So here, the samples are grouped based on the R-square values from low to high. So we start with the samples that are very weird, and they're fitting the curves very weirdly. And as you scroll through them, the data will fit the quadratic curve better and better. There's something important to know, that although we're fitting quadratic function, the line that you see in here is linear, and that's because we are using a linear model, but we are transforming our phenotype with the square root function. So that's basically forcing the phenotype into a linear function, and then we transform the coordinates back so that the function is quadratic. So you can use those R-square values and get rid of samples like this by using the R-square as your selection criteria. So right now we've got the R-square threshold value at 0.7, but you can of course change it in here to even more stringent or more relaxed value. And then download the samples that are free of the free of the outliers based on your R-square cutoff. All right, and then what you also want to do is maybe to examine the differences between your genotypes. So that will take a couple of seconds. And then in here what we see is we see a growth rate of different genotypes in two different conditions. So here we see an ANOVA report of those growth rates. So we see that the effect of the treatment is significant, the effect of the genotype is significant, and the interaction between them is significant. So right now we're using all of the data, but what we also can do is we can use the data that where the R-square value below that cutoff value is removed, and see how the graph is changing. You can also adjust that and see how the graph, how differently will the graph look. You can of course change the appearance of this graph. So right now we're doing box plots just because it's the most honest representation of your data, but if you prefer to use scatter plots or bar graphs, you can do that as well, and then you can download the plot in here as the PDF, and then change the error bars. Right now they are standard error, but you can also change them into standard deviation if you prefer to do that. And although we have an ANOVA report in here with the p-value, if you also would like to know what is the difference between individual genotypes in this case, you can also scroll further down and see in here a result of a pairwise comparison tests between different accession in control conditions and in salt stress conditions. And of course you can download the summary statistics of the model data in here as the CSV file.